We all know what happens during acid-base titration. Salt and water are formed. So what is the pH of this resulting solution? Yes, it depends on the type of acid-base titration, and hence the pH of the resultant solution could not be 7 always. Now what are the types of acid-base titrations? Strong acid, strong base, strong acid, weak base, weak acid, strong base, and weak acid, weak base. These are the different types of acid-base titrations, and the pH of resulting solution depends on the nature of salt formed after this reaction. The salt interacts with ions of water and solution becomes either acidic or alkaline based on the nature of salt, and such interactions are termed as hydrolysis. Let us see one by one for each type of titration what exactly is happening. In case of strong acid strong base titration like KOH HCl, NaOH HCl, you can see here the salt formed is KCl and NaCl respectively along with water. Here neither do anions have tendency to combine with H plus nor do cations have tendency to combine with OH minus of water, because the related acids and bases are strong electrolytes and these are completely dissociated, and therefore equilibrium between H plus and OH minus of water is not disturbed, and thus solution remains neutral. So here pH is always 7. Now look at this example of weak base and strong acid. So weak base is ammonium hydroxide and strong acid is hydrochloric acid, and NH4Cl plus water that is formed. Abhi NH4Cl means what? NH4 plus and Cl minus. Now here not Cl minus, but definitely NH4 plus has tendency to combine with OH minus of water, and therefore OH minus of water is reduced and H plus is increased. Hence the solution ka pH, the resultant solution pH is acidic. Now in this next example of weak acid and strong base, for example KOH and HCN, that is hydrocyanic acid, the salt formed is KCN and water. Okay, so KCN gets dissociated into K plus and Cn minus in presence of water, but here among these two ions not K plus but Cn minus has tendency to combine with H plus of water, right, and therefore concentration of OH minus will increase here, and thus the pH of the resultant solution will be on the basic side. In the similar manner, the acetic acid and NaOH example can be considered, where CH3COO Na salt has been formed and CH3COO minus will get combined with H plus, and therefore the OH minus concentration of the solution will increase. Now in this next example of weak acid and weak base titration, CH3COH, that is acetic acid and ammonium hydroxide, they are reacting with each other, they are trying to neutralize each other. In the process the salt which is formed, that is ammonium acetate, it can get dissociated into CH3COO minus and NH4 plus. Now both of them have tendency to combine with H plus and OH minus of water, and here it depends on the dissociation constant of acid and base. I mean respective acid and base, unka dissociation constant pe the pH of the resultant solution will depend, and that pH we can calculate using this formula. This is my another video present on the channel where I have given detailed short note on the neutralization curves. Now under this neutralization curve, the basic concept we have discussed just now, but along with that concept you have to show such different graphs, that means the curves under each type of acid base titration. You have to enlist the different indicators which are used under each type of titration. What is the neutralization or equivalence point, that means whether the pH of resultant solution is more than 7, less than 7, or it is 7. How and why weak acid weak base titrations are very difficult, why we can't see the end point, and why we do non-aqueous titration for weak acids and weak bases. Everything I have explained under that video, so you can go and check. Thank you for attention. Have a nice time. All the best.